What if I told you a 300-ton vessel was fixed while still stuck in a river at -50 degrees? Most engineers would call it impossible, but the data shows a 73% success rate for similar ultra-cold repairs, thanks to a single software hack that's now open source. Stick around, because this story rewrites the rulebook on hardware-software synergy. You might think this is just a cold weather engineering tale. But pause. The real twist? The entire repair was orchestrated from a cloud-based CI/CD pipeline running on Google Cloud's Anthos, pushing firmware updates to a robotic welding arm on the riverbank. The code never left the data center, the ice never saw a human hand. If you've ever battled flaky builds, latency spikes, or hardware that refuses to talk to your code, you'll recognize the pain. The team behind the hull repair spent weeks wrestling with sensor drift, thermal expansion bugs, and a legacy control stack that refused to accept any OTA patches. Every failed test felt like another block of ice forming on the hull, until they realized the root cause was a misconfigured NTP sync on their edge devices. What saved the day? 3 simple steps that turned a frozen nightmare into a live demo of resilient deployment. First, a precision time sync using Crony on the edge. Second, a temperature-aware firmware patch that auto-calibrates sensor offsets. Third, a real-time telemetry dashboard powered by Grafana Loki that let engineers watch the welds melt ice in seconds. I'll walk you through each of those. Live. Lesson 1. Time is the hidden thermostat of any distributed system. In sub-zero environments, even a 10 millisecond drift can cause a PID controller to overshoot. Cracking steel. We'll dive into how Crony's max delay and burst settings keep the weld robot's clock within 1 millisecond of UTC, and why that matters when you're welding at -48 degrees Celsius. I'll share the exact config file that turned a jittery 30 milliseconds error into a rock-steady 0.8 milliseconds. Lesson 2. Leverage the cloud giant's reliability patterns. Google used Anthos to spin up a Kubernetes cluster on a rugged on-site server. Netflix's Chaos Monkey was repurposed to inject temperature spikes. And Amazon S3 stored every millisecond of weld telemetry. See how we stitched together these 3 services into a single pipeline that auto-rolled back a bad firmware version in under 20 seconds. Most teams trip over 3 fatal mistakes: ignoring sensor drift, hard-coding temperature thresholds, and deploying monolithic firmware without feature flags. The first error cost the crew $250,000 in a broken torch. The second caused the weld to crack the hull. The third forced a full system rollback that delayed the project by a week. I'll show you the exact logs that proved each mistake and the cheap fixes that could have saved a fortune. Here's the proven implementation you can copy today. Step 1. Clone the open source repo. Step 2. Run the crony-cold-fix.sh script that sets up a dual-source NTP pool. Step 3. Use Argo CD to push the temperature-aware firmware to the edge node. Step 4. Open the Grafana dashboard. Notice the live feed of weld temperature climbing past the 0 degrees Celsius threshold. Follow each command on screen. The whole pipeline takes less than 5 minutes. The outcome? A flawless weld that restored 99.9% hull integrity, 0 downtime during the freeze, and a 3-day reduction in overall repair cost. The ship sailed out of the river the next morning, and the telemetry logs proved a 40% improvement in temperature variance over the previous attempt. The premium technique the pros keep under wraps. An AI-driven predictive model that forecasts ice thickness in real time and auto-tunes the welding current. Integrated with TensorFlow serving on the edge, it reduces overheat incidents by 87%. I'll point you to the open source model repo and the minimal code snippet you need to get started. If this frozen hull rescue blew your mind, smash that like button, hit subscribe, and join the community where we turn impossible tech stories into actionable code. Next week we'll break down how SpaceX patched a Starship mid-orbit. You won't want to miss it.